Hey guys, so as Kim said, I'm Adrian, ex-OWASP guy. I'm a pen tester, I'm a developer, I review a lot of code, I spend a lot of time reviewing code, normally for security stuff, and I've done the odd occasional secure development training kind of thing. So source code is my thing. I love source code. So this is a talk I've been thinking about for a while. I don't have a lot of time. I could rant about this stuff for hours, but I've only got 45 minutes. So I'm going to go pretty fast, so try and keep up, strap yourselves in, it'll be great. So as kind of pen testers, we talk a lot about vulnerabilities, we talk a lot about fixes, but we don't really talk about what secure code looks like, how it's designed. So I've been kind of like, it's been kicking around in my head for a while as I'm reviewing this code, is like what kind of source code patterns and what are the developers doing when they introduce vulnerabilities into their code base. So I'm going to be getting into that, but before that I need to kind of cover off a couple of things really quickly. So code patterns. So this is something that developers generally understand pretty well. It's all about how you architect your code, how everything fits together, what code goes where and how it talks together and what the abstractions are and that kind of crap. Developers are good at it. Hackers, pen testers and hackers generally aren't unless they come from a development background. Because let's be honest, hackers don't write good code. They write hacky code that works right now. And they don't care if it doesn't work a week later. And that was something that took me a while because I started in development and then moved into pen testing for a number of years, and now I kind of do a bit of both. It took me a while to kind of get my head around that I don't have time to write this nice, elegant bit of code in order to exploit something. I just got to make it go, because I had a couple of guys behind me like standing over me saying, hey Adrian, where's that code? Why isn't it working? And I'm like, oh, but it's not beautiful enough. So anyway, so code patterns. So patterns are about how a program is designed roughly. I'm not using any kind of strict rules on what I'm calling it. It allows us to easily understand code. So if I look at a code base that's got some really strong patterns in it and it's done consistently, I can make a bunch of valid assumptions about how the code works and where things are, and it makes it a lot easier to understand. And it also saves us from ourselves. So a good pattern provides a good way of doing something within the code base versus a bad way. So we're all hopefully relatively familiar with this pattern, so you don't really have to look at the code. So MVC, model view controller, you've got your model, you've got your views, and you've got your controllers, right? And each has its own set of concerns, and they all do tiny little different things and whatnot. But what it does is it gives us a way of logically splitting out the different bits of code that needs to do different things, which again lets us make a bunch of valid assumptions and understand code a lot easier. Now this code is from a project that I was working on, I don't know, a month ago. And now this is what I describe as a steaming pile of shit, right? So hopefully you can kind of see that. It's not really following any pattern, it's all kind of mishmashed together, and it wasn't great. So what does the code patterns? Normally when we talk about patterns, we're talking about how to make your code maintainable and extensible and understandable. But often, people don't really talk about patterns and security. So with this model view controller pattern, we can say, there's a model here, right? It abstracts the database layer. So that one cares about SQL injection. Cool. That's the view. So this is the thing that generates the HTML, right? That thing cares about cross-site scripting. And then the controller cares about things like access controls. There's a whole bunch more. But my point here is that if I'm looking at a controller, I don't have to give a shit about cross-site scripting because it's not relevant 90% of the time. Anyway, there's always exceptions, but in general, it's totally not relevant. So as a developer, as a code reviewer, as a security guy, I can forget about that, and I have to think about less things, so there's less cognitive overhead, and it makes everything easier and nicer, right? Okay, so back to this code. No pattern, but we've also got this crazy anti-pattern down here, so I was kind of shocked when I saw this. They're generating JSON by using string concatenation and just... what the So anyway, yeah. Okay, so, summary, patterns. So a good code pattern is a good way of doing something, an anti-pattern is a bad way of doing something. And you got the kind of thing in the middle, which is like no pattern, and what could go wrong, right? Okay, so security can be at odds with otherwise good code. So this is essentially the crux of my talk. Security can be at odds with otherwise good code. This is a problem, right? Because as a developer, you want to write the most elegant, small, easy to understand code that you can. However, sometimes that code has horrible, horrible insecurities in it. So when you're a developer trying to do, you do the best job you can, but you don't understand security, you introduce bugs, right? So, shit. So when you get it right, you've got a good program, it's well designed, it's easy to understand, you've got devs that are happy, they're less rushed, they can do things quickly, and it's easier to bring new people in on the project. So you hire a new junior dev and he comes in and you're like, hey man, do this thing. He's like, yeah, I can do the thing, and he does the thing and it's great. So when you do it right, you have less bugs, and always a portion of bugs are security bugs. So good secure program design is slightly different. So one of the things I kind of want to stress here is that developer user experience. That's a thing, right? That's a thing that I've never heard anyone really talk about in that set of words. So when you talk about UX, user experience, you're normally talking about the end users and like how easy it is for them to log in and click the widget and that kind of crap. Developer user experience is all about the languages that are chosen, the libraries and the frameworks and the code patterns. So developers want to use languages that are fun, I guess. So if you go to a developer and say, hey man, what are you going to write this in? He's going to choose something that he understands really well and that he likes, or she's going to be like Haskell, and the rest of us are going to go, oh shit. So you're looking for, as a developer, you're looking for stuff that's kind of, it makes it easy to get your job done. So lazy developers are good developers. So this is kind of it sounds like an insult, right? But it's totally not. Lazy developers write smaller code. They don't implement things that they don't need to. They use libraries. Other people's libraries have been well reviewed and da-da-da-da-da. Because writing code is hard, so let's be lazy, not do it, use other people's, fit it all together, right? So in order to have a good developer user experience and also be secure, the secure way needs to be the easy way, and it also needs to be secure by default. So it means that you can't shoot yourself in the foot because you don't know what you don't know. So, modern web application frameworks. So these things are great. So, I guess Ruby on Rails is kind of like the main big one that came out years ago that people were like, whoa, this thing's actually cool. We don't have to have XML and crap. So we've got these frameworks, and everyone's starting to use them, and it's cool. And things that they do really well from a security point of view is generally request parsing, database, create, read, update, delete operations, so basic selects, deletes, inserts, and HTML generation, right? But I don't know, the request parsing, like, except YAML in Ruby on Rails. If you don't know what I'm referring to, just look up Ruby on Rails remote code execution. That was a problem. But I was like, surely there's more. Like, surely there's more that these frameworks do really securely. So I couldn't really think of any. I'm sure there are, but I couldn't think of any. So these are things that we also do when we're writing web applications. We deal with authentication, authorization, search, file upload, image processing, all of this kind of crap that these fantastic, opinionated, fun, good user experience frameworks, they don't really give you any indication as to how to do it. Sometimes they do, sometimes they don't. But in general, a lot of the stuff is just like you're kind of left on your own. So you can kind of see where I'm going with this. Is that we've got these great frameworks, and if you use them correctly, you can have a lot of good security controls. But they don't really go that far. They're opinionated, but not opinionated enough. So, for example, every single time I've had to write an LDAP query outside of .NET world, there is nothing for me to be able to write that query and make it safe from LDAP injection, which is a vulnerability of some sort, without having to write a whole bunch of crazy validation code. It's just not there. The framework and the libraries just don't exist in the stuff that I've been using, and it's been a real pain. So the framework saves us from some things, but my point is with all of this is that developers have to know security. So welcome to OWASP Day, everybody. However, we can't really expect our junior developers who are still kind of at the point where they're just trying to string code together so it actually works to understand larger or be able to also implement larger design patterns and also do security and kind of all of the other crap. So this kind of has to come from the senior developers to make sure that people are kind of doing what they're supposed to be doing. And also, if you're a pen tester, there is a lot of work out there left. We're not going to be out of a job anytime soon. So, let's start with cross-site scripting. So I'm not really going to talk about what cross-site script or how cross-site scripting works. Suffice to say that it is about me as malicious hacker injecting JavaScript into your browsing session and like stealing your password or whatever. You can do a bunch of crap with it. It's fantastic. So root cause, right? Root cause of cross-site scripting is generally it's generally all about how you are generating HTML. So I just said that these modern frameworks are really good at generating HTML in a secure fashion, and they are. However, what I've found is stuff like this, where people are like, okay, so I've got this normal request response flow where a request comes in, it gets decoded, it hits my controller, do some crap with it, and then I return a response with like some data in it, and that gets automatically put into a template and spat out to the browser. Right? Easy, fine, good, secure, everything's happy, until you want to go send an email. Now, email clients parse HTML. Now, they don't parse JavaScript, so this is not cross-site scripting. However, this is a pattern that I see all the time because people don't have that kind of request response kind of thing going on here, and they're like, oh crap, I need to do HTML, but I can't use the framework's standard way of doing it with their templates. What do? Like, what do I do? Like, ah, fuck it, I'll just do this, right? So we're gonna see if I can show a little bit of a demo going on here. So this is a new email client called Firefox. No, just imagine this is an email client. It's not, but and imagine that there's a website that you can send in. You can put in someone's email address and send them an invite. Right, so I'm going to send Timmy an invite, and he gets an email, and it looks like this, right? Hey, Timmy, do you want to register? Yes, sweet, you've got X amount of time to do it, blah, 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 blah. So what I can do when you've got this crazy HTML generation with string concatenation is start putting HTML in here, so everything becomes bold, okay? Fine. So there's no JavaScript, it's in an email client, what are you going to do with this, right? Why is this a big deal? And to be honest, it's not. This is not a big deal. But it is an anti-pattern as far as generating JavaScript. So what I can do in this case is what I'm going to do is actually comment out, whoops, let's just go back, is comment out like this, so there's nothing after it, and then I'm going to say, what I want is let's say a header tag, and then buy more firewalls. All right? So you can start to actually control their user on the internet can control what ends up in that email, or quite a lot of it, right? So if you're a spammer and you want a way to send a bunch of spam using someone else's servers, maybe you'll do this. Maybe you'll do this. So from a risk point of view, this is relatively minor. But this kind of HTML generation anti-pattern is something that we should always be looking for in your source code. So how do we do it right is the next question. It looks like this, basically. So what I've got is a template at the top, and then I'm building a model, and then I'm grabbing a template compiler, and I'm compiling the template, and then I'm executing the template with the model, and then I'm using that to send to the server. Now, looking at that code versus this code, which one is shorter? Which one is more elegant? Which one is easier to understand? Right? And I would say this one. Because there's less lines of code, there's less going on, it's easy to see what the hell is going on. Well, this has these crazy template compiling kind of crap. So if you don't know about HTML injection, cross-site scripting, those style of things, you can easily see why you would choose that. Because it's, apart from the security implications, it's better code, I guess, nicer code. So one of the issues I've always found with trying to get access to, using a template engine outside of the normal request response thing is how do you actually get to that template engine? And the different frameworks that I've used have different ways of doing it, but it's generally pretty well, undocumented. But anyway, this is some code that I found in the last source code review I did a couple months ago. This is some JavaScript. What it basically does is select all the select boxes and then iterate through them and then add another option to the top. And you can see the same string concatenation, the same anti-pattern where the HTML is a string in JavaScript land, and then it eventually gets added into prepended to the top of the select statement adds this other option thing. So I was looking at this, I was like, yeah, that doesn't look good. This is, again, this anti-pattern idea. This would be exploitable if the title attribute of the select node in the HTML was controllable by a user or some way. Now, I don't know, I never got that far because tracing that kind of stuff is a pain and the client didn't want to pay for it. So they got a report saying this may or may not be a problem, but again, it's anti-pattern, shouldn't do it. So developers, never use string format or concatenation to create HTML, just don't do it. Like, you should never see this crap, but we do. Template engines are great. The DOM, the JavaScript DOM, if you're doing it in JavaScript, works really well, but you're probably using Angular or something like that, so you probably don't need to care about that. So if you're a senior dev, work out how to get access to this template engine, because it's often kind of tricky, it's kind of hard. Devs, being lazy devs, don't want to do hard things. They want to do nice, elegant, easy things, right? So, but you got to kind of do it. So document it, show the team. If you've got your own libraries that you pass around that are included in every project, if you're a shop that does that, maybe you put your own abstractions in there, My point is, templating engine, work out how to use it, and use it. If you're in JavaScript land, this is kind of what you could do if you were not using jQuery or any crazy libraries or anything like that. But the point, or the trick is here, is that you see that p.innerText is nya, and that's fine. You're not getting any HTML injection or whatnot. If you did inner HTML, you're screwed. You have cross-site scripting. So if you're going to use the DOM, it doesn't really, it's not secure by default. You've got to get the right things. You just got to be careful with it. So hackers. Originally I had pen testers up here, but this is actually more aimed at hackers because fuck it. Pen testers have to get, the idea is all the bugs all the time, or most of the bugs most of the time, be thorough. Hackers is about getting in right now. So pen testers, if you're doing like a red team engagement, or if you don't need to find all the bugs, you just need to brutally hack something, this is what these recommendations are more aimed at. So work out, is template engine used at all? If it's not, there's probably going to be cross-site scripting everywhere. Look outside of the normal request response flow. So often if it's a modern framework and there is that, request comes in, controller deals with it, there's some model actions and crap like that, and then there's that well-defined template. That flow is really well-defined, it's understood and generally quite secure. However, if there's some other crazy functionality like this ajax.php URL, for example, that probably, if that differs from what you're normally seeing in the URL structure, that's probably a bit of different functionality, and it's probably worth investigating that because it might not use that standard secure flow, which is actually a theme throughout this, throughout my recommendation for the hackers, is always look for outlying functionality, weird shit, because that's where the secure by default and it all kind of goes out the window. So if you've got the source code, check out the stuff that includes the routing and adding new servlets and the ASHX handlers and .NET World and all the kind of crazy crap, which is great. This is something that I really enjoy finding is when you got server-side, the server is generating an HTML template with some JavaScript in it, and they're taking some data that's on the server and dumping it into a JavaScript string. Now, what happens is that you can be escaping for HTML, but it's actually in JavaScript land, and the whole escaping and encoding thing is all totally different. So it's normally kind of breaks. Also, when you end up with, say, user controllable data in like the title tag or in like some crazy inline CSS and crap like that, often template engines don't support that. They don't support it well. So maybe you can find some cross-site scripting and that kind of thing. All right, so that was kind of patterns and anti-patterns for HTML generation. Next one, SQL injection. So again, I'm not really going to talk about SQL injection or how it works. Unfortunately, I don't have time. Basically, SQL injection is where you can inject your own stuff into a SQL query. So in this case, if I typed in a login box, Timmy, single quote, space, hyphen, hyphen, which is a comment, it changes the logic of the query because the database starts interpreting that Timmy, single quote, as code instead of just a username. So if you want to learn more about SQL injection, there's a shit ton online, and go do that. So this is the classic SQL injection code pattern that we see, is where they've got a string, it's got SQL in it, and they're just concatenating something into it. We don't see that, I very rarely see this anymore. SQL injection has been around for a really, really long time. People are pretty aware of it. and we have these things called object relational mappers. So this one, probably don't really see that because you don't need to. There's nicer, more succinct, more elegant ways of doing this in your code. So, you know, developers being lazy, they're not going to do this. Now this one is slightly different. So on the right is the object relational mapper way of doing it. So there's no SQL in here. This is just an abstraction layer that comes with most modern frameworks. They're all kind of slightly different. This is SQL Alchemy, I think, similar to. And you kind of build up this query. So what it's doing is it's taking the user input, which is a search term, it's splitting it into words, and then in each word it's kind of adding an OR clause to the query. So one of the things to notice here is that this SQL query that's going to come out of this is pretty dynamic. It's like the where clause will change based on the user input. So there could be more ORs or there could be less ORs. So doing that, in this case, on that one, on the right, using string concatenation, you can, and I do see this pattern quite often when it's not a simple, I said, a simple CRUD, create, read, update, delete operation. When you actually need to generate a query that's it's a little bit more interesting. However, the SQL Alchemy actually looks better, so that's kind of, that's better code, right? So you've got the bad anti-pattern, and then you've got the good pattern. Right, it's kind of obvious, but as far as like code complexity and how pretty they are and whatnot, the ORM one looks a bit better in this case, but not by a huge amount, right? Until when good frameworks go bad. So, I was working on a development job, and I was using Spring Boot, which is an interesting framework, and I wanted to search, right? I just wanted to search for some stuff. Now this shouldn't be hard, right? It's pretty, you just search, right? So I was like, okay, crap, I don't know this framework that well. How am I going to do this? Ask Google. Google comes back with like, you should do this, right? Do this. I'm like, okay, cool, right. I can make that work. And I kind of copied and pasted it in and moved some things around to fit how I wanted. And you'd think it would work, right? You look at that, you're like, yeah, that would work. Yeah, that makes kind of sense, I guess. It doesn't work. That's not going to work. And nobody really tells you why it's not going to work. Maybe I just skim read too quickly and missed that part of the 3 or 4 blog posts that I read about it. So the first thing that kind of stood out to me is you've got this kind of document underscore. Actually, can you see my cursor? Yeah. So document underscore here. So what the hell is that? So I didn't write that. So in Java, there's got to be a class, right, called document underscore. I didn't write that class. That class doesn't exist. What the hell? Where did this come from? And it turns out that what you need to do is you need to go and find this crazy Maven plugin that will then scan your code at compile time and generate these meta models based on what your entities look like. And I looked at that and went, oh, I don't want to do this. This is hard. Because I'm a lazy developer, right? I don't want to make it hard. Then you've got this crazy root thing, like what the hell is root dot? And then you've got the generics and it's all, and then on top of it all, this thing returns a specification. It doesn't even give you results, it returns a specification for some results. So you've got to have some other code somewhere else that handles the specification. And I'm not an expert in Spring. I learned a lot about Spring, but anyway, at the time, I didn't know shit all about Spring. I was like, this sucks. So you can kind of see, when you run into all of these crazy problems, why you might go back to like the string concatenation thing, right? So this is hard. It's not obvious. And devs don't like hard, non-obvious, right? Because it's bad. You can't. If there's a massive learning curve for someone and you hire a junior and they have to deal with it now, they're going to have problems, and you're going to have problems because they're having problems, and it's all going to go horribly, horribly wrong. So, as a lazy dev, you kind of find another way, and you end up with this because this is code you can understand, and it does what you think it does if you don't know anything about SQL injection. Right? So it would be better code. This would be better code if it wasn't horribly insecure, which it is. So it's terrible. This is another one that I find quite often. So this is like a prepared statement. So the search part, which is the data, is totally separate, or the search variable, sorry, is totally separate from the actual string, or the SQL code, which is great, except for it's using a string format to include this limit. And I see this quite often because developers, they know about SQL injection. They're like, yep, SQL injection is terrible. What I'm going to do is use a prepared statement. However, for some reason, they think that you can't inject into the limit clause or an order by clause or a table name or a column name or something like that. So like, I know of one example of some dev shop somewhere that was building some software for a company that a friend of mine works for, and they thought it would be a great idea to have this user interface, and they had all the SQL in the JavaScript, and it would just send it off to the server, and the server would execute the SQL and give back the results, right? So the company, when they kind of clicked onto this, went, what the fuck? You guys need to fix this, because this is stupid. And the response from the company is like, oh yeah, no, that's not good. We will fix it for you. Their fix was to hard code on the server side select word, the select in a string, and then the front end would now only send everything after the select. Yeah, so that caused some problems. So you see my point. Anyway, so devs, ORMs are your friend, object relational mappers, active record, that kind of crap. They're your friend even when they suck. And normally they don't suck, but sometimes they do, and you just have to love them anyway. I've wrestled with ORMs trying to generate the right SQL that I want because it's doing something stupid. And you just do it. Just do it, just suck it up. Never use string concatenation, string format. And injection is possible anywhere. So hackers, SQL injection is still a thing, yes. So look for the stuff in the complicated queries. So many times I've looked at a web application and I'm like, hackety hack, no SQL injection, no SQL injection, no SQL injection, no SQL injection. Oh, there's this crazy advanced search thing with like checkboxes to toggle stuff and multiple inputs and blah, 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 blah. And that has SQL injection in it for this reason, because the ORM sucked and it was hard. So someone went back to the whole old SQL concatenation thing. So again, look for non-standard functionality. So if you've got your standard request response controller models kind of deal happening, that's all fun and good. It just gives you the ORM to deal with. You've got the models, right? But on some frameworks, if you need to have a bit of functionality over here that doesn't follow that standard pattern, then perhaps the ORM is no longer available, and getting access to it is going to be hard. It's going to be a pain. So what do? You just write SQL again. And I've seen that multiple times. So SQL map is like the tool for the exploitation of SQL. So I was going to actually do a demo of SQL map and some SQL injection and so on and so forth using Python Flask and a SQLite database. And SQL map just failed. There was a basic union injection. You go, hey, SQL map, do this thing, and it looks at it and goes, no. Yeah, so SQL map is interesting to look at. I'd recommend you'll go take a look at it to kind of understand the power of SQL injection, but it sucks when you actually need to exploit stuff. Like I've had, it just doesn't, it works sometimes, but if you're the kind of pen tester who can only do SQL map, you're not a pen tester. Sorry.
It remembers what happened last time you ran it.
Yep.
So you leave a cache.
Yeah, or run it within the flush switch, right? Which I tend to do just because SQL map, right? Okay, so that was SQL injection. Right, insecure direct object reference. So this is part of the OWASP top 10 as well. I do not know why OWASP decided to call it this, because that name is confusing as hell and makes no sense to me anyway. So what the hell is a direct object? So a direct object reference is a reference to an object, right? So normally it's a primary key for a database row. It can be a file name, for example, something like that. And it's insecure because you have a lack of access controls. So if I was going to name this, I would say you have a lack of access controls to access data, right? Not this crazy direct object reference thing. But pretty much how it works is the standard case is that you've got a URL, and like we're going to say run a GET request at profile 1, and we are, say, profile 1, so we're allowed to access it. We're a low privilege user. We shouldn't be able to see anyone else's personal information. However, we just add a 2 and get someone else's information, and 3 and add get someone else's information, because there's no access controls protecting other people's crap, right? So what we're talking about here is authorization. So there's authentication, which is saying who you are, kind of. It's like the login, the username, password part, verifying you are who you say you are. And then there's authorization, which is different in that it's saying, we know who you are, but are you allowed to access this stuff? right? So this is all about authorization. So who can access what? And it is critical from a security point of view, like absolutely critical. Like if I'm a low privilege user and I can create, say, an administrative user, all of your access controls just go out the window. I now own your web application. It's great. But it's actually kind of hard from a dev point of view. And I've never really seen, like there's a few libraries from security and crap like that float around that you can use and people do, but I've never really seen people talk about like, this is how I think you should implement this thing. So I'm going to present to you Adrian's amazing 3-tier system, right? 3 steps to success. So tier 1, right? Tier 1 is the user authenticated? So this is obvious, right? This is pretty well understood. So normally they'd log in and you store something in their session and and generally you'd have a whitelist of URLs that they can access. So if you're not authenticated, you are allowed to access the login and you've forgotten your password. Blah, 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 blah. It's normally like a global filter and it's fine. People generally understand this one, right? But what goes wrong? So insecure defaults. So blacklist versus whitelist. You've probably heard security guys rant about blacklist versus whitelist all the time. Blacklists suck, whitelists are the way forward, so on and so forth. So the thing about a blacklist, so if you say, if you're not authenticated, you are not allowed to access this functionality, then what happens is some dev comes along 3 months, 6 months, 2 years later and says, right, we need this new bit of functionality, I'm going to add it. And they didn't even know that authorization filter over here with the blacklist existed. So they don't update it. So they add the feature, they test it, it all works, everything's fine, and it goes into production, and then all of a sudden you've got this bit of functionality that is not included on the blacklist and is not being protected from unauthenticated users. So this happens all the time. So that's why blacklist is bad. A whitelist, on the other hand, would by default not allow access to it if you're not authenticated. So that's secure by default, which is one of the main design patterns that we're looking for when you're designing a secure program. So secure by default is absolutely critical. A couple of things I've found is like allowing users to modify the session object. So like if you can modify that, you can make yourself look like anyone. And it sounds wacky, but I've seen this a couple of times where there's some functionality that eventually allows you to totally control the server-side session object. Can also happen if you've got the session, say, serialized in a cookie, but you're not verifying integrity and that kind of crap. And other authentication issues that we don't care about. Okay, so tier 2, is the user allowed to access this functionality? Okay, so this is pretty well understood, but maybe not. So this is normally role-based, and you'll have a list of roles, and you'll say, all right, you're this role, therefore you're allowed to access these things. And you're this role, you can access these things. So I'm talking at like a controller method level, where it's you've got, say, a function that creates a user, you've got a function that deletes a user, you've got a function that updates a user. So each one of those, you would specify what roles exist, or what roles, should be able to access those. Now that's not too hard, right? But what goes wrong? Again, insecure defaults. So for example, if you forget to specify what role should access something, then no one should be able to access it. It should just be inaccessible, which is absolutely critical, again, when changes are made and you've got a new dev who doesn't know how the access controls are supposed to work and that kind of thing. And the whole blacklist, whitelist stuff. One issue I found was a mismatch between functionality and the URL. So they were saying, okay, this URL, which was, say, create a user, this URL, is only available to administrators. But there's a difference between the URL and the code that actually runs, right? So, because in between you've got this router, and the router parses the URL path and then decides which code to actually execute. So they had these access controls that would look at the URL and decide whether you could access it, and then they had the router which would look at the URL and decide what bit of code's running. 2 separate bits of code. And what happened is that I discovered that the access controls didn't do any normalization on the URL, but the router did. So I added a plus and a space in between, say, API create user. And that plus and the space got transparently removed by the router, but was parsed as normal by the access controls. So adding that, coupled with a blacklist, totally broke the access control. So I could access any functionality just by adding the plus and the slash, which was fantastic from a pen tester, hacker point of view, but pretty shitty from a developer point of view. So another thing that goes wrong is unclear business rules. So who can access what? It's actually a really tricky question to ask someone. It's like, hey, So we've got all these kinds of users, and we've got all this kind of data. Who can actually do what? Because some of it's obvious, some of it's a business decision. So tier 3, who's allowed to access this data? So they're authenticated, they're the right role to access functionality, and now they need to, say, be able to access the profile. And they're only allowed to access their profile, or they're only allowed to access the profile of the people who are, because they're a reseller, their clients, right? So this is hard. This is where it all falls apart. This is where people get it wrong. This is where I've found so many problems. Because there's no way to do this in a secure by default manner that without having some crazy historic database layer. Like, I'm not saying it can't be done, but I am saying that it's a real bitch, and I've never actually seen anyone pull it off properly. So you can't really do secure by default here. You have to have bespoke code somewhere in your controller or your service layout or somewhere that ensures that only the right people, only the person can access the data that they are supposed to. So often this will be in like the SQL where clause or something like that. So again, the insecure defaults, the blacklist, unclear business rules, changing business rules. So the business rule thing. So many times I've sat down in a meeting with the guy, like the business guy, right? The guy that's the project sponsor. And I've said, okay, so we've got this kind of data, these users, who can access what? And you can't get an answer. It's just, shouldn't be hard, but it is. And who's been in this situation where they're trying to nail down requirements for access controls? Yeah, a few people, yeah. And it's just like pulling teeth, right? Yeah. So anyway, getting that right is surprisingly hard, and it's frustrating. It's really frustrating because as a developer, you want to be writing code. You want to be not making this nice, elegant code. You don't want to be sitting in a meeting with a business guy trying to extract that information out of it. So it's often overlooked. Often the logic is unclear and that kind of thing. So devs, tier 3 control should be as close to the code as possible, as should tier 2. Whitelists, if you're going to do like a filter with whitelists, should be global. Yes.
Faster.
Okay. So recognize tier 3 is hard. So tier 3 is hard. Understand the data that you're dealing with. Understand the kind of users that you're dealing with. So extract, and I do mean extract. Extract the business rules from the business people. Who can access what? I've been timing myself. I've got another 5 minutes. So, you're running off a clock. God damn it. See, this is the problem, right? Getting the rules. It's hard. So cover each scenario, ask questions, get the security guy to pull holes in everything, and then test your controls. Like when you're a developer, test that they work, test that they don't work. So hackers, checking access controls is tedious. It's really tedious, but is pretty critical to the business. But if I just want to hack this thing, use your common sense. Like, I don't really care if you can like set someone's shipping address to primary, like someone else's shipping address. Doesn't really matter. If I get access to a bunch of people's personal information, or if I can create a different user or something like that. Again, look for weird functionality. So we are going to skip all of this. So, modern frameworks, they won't save us. They are much better than what we used to have back in the old, say, ASP days. Non-junior developers you have to know security these days. You have to know security. And I'm talking like kind of preaching to the choir here because you guys are at a security conference. But for those of you who are here representing your team or part of a team, when you go back to your team, you are now the guy, right? You're the security guy because you came to this thing, right? And you need to kind of educate people on how to design their code. So junior devs have to have guidelines how to not mess it up. Code review is really important for people. Like, if you've got a code review checklist, security should be part of it. Like, stuff like, this is how we do authorization. This is how we do mass assignment. This is how we do blah, 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 blah. So we've talked about patterns, a bunch of anti-patterns, where it goes wrong, why developers mess it up, and normally it's because they're trying to do a good job, because they're trying to have elegant code, they're trying to have small code, and they don't understand security. So, as pen testers, we should stop being mean to the developers. As developers, you guys should just be better. So always be thinking, like, when you're designing your program, always be thinking, when a new junior developer starts, and he's going to be green, or she's going to be new, when they start, what might go wrong? Where are they going to make the mistakes? And then how can we design our program so that they understand and it's obvious the right way to do it, and the right way is the secure way, and the secure way is the easy way. Thank you.